Hi, and welcome to week 6 of Signs and Symbols, Enhancing Science Instruction Through Literacy in the MCCS Era. We're working here on part 3 of this week's presentations, which is inquiry. So to start with, we want to build a little bit of common understanding. Today we're going to be talking about inquiry learning in its general form, which is an example of a common and powerful constructivist learning environment. There are some other constructivist learning environments we could use here, but because inquiry is so common, we're focusing on inquiry instead of focus on things, on some of the other more kind of niche environments that are out there. It's important that we make this statement about the general form of inquiry because we're going to discuss a little bit about scientific inquiry. But those of you who've spent a lot of time learning about scientific inquiry and kind of have a strong background knowledge on that, it's going to be important to recognize that we are talking about something a little bit more general as our basis here. Not that scientific inquiry isn't part of the larger inquiry theory, but as we move forward towards things like the practices and the framework, it'll be important for us to be able to distinguish a little bit more between the inquiry learning environment in general and, for example, steps of scientific inquiry. So the very first thing we want to do is give some information about why inquiry falls into the constructivist family. So we have these three things: the student-centered or learner-centered, the teacher as the guide or facilitator, and this active process of knowledge construction. All three of these are integral parts of all constructivist environments, and they're also part of inquiry. So within inquiry, as we talk, we want to make sure that we're thinking about how the student is able to either change the direction of the learning environment or set the direction of the learning environment once we've entered that inquiry learning process. Also, we want to think about the teacher as guide or facilitator. This is similar to with the ZPD or scaffolding, this idea that the teacher needs to be there as support to guide and facilitate those pieces that the student isn't ready for. And when we look at the really extreme forms of inquiry that are out there that are very much run by the student, the teacher still is there as that guide to answer questions and to provide information. And then the third part, the active process of knowledge construction. Whenever we're in an inquiry environment, we want to make sure that we have explicitly provided learners opportunities to build their own knowledge by selecting, organizing, and integrating information with prior knowledge, and that we haven't kind of left that part out because that active process of knowledge construction still needs to happen. This is an image of the very basic inquiry cycle. I like this one because it's not content specific. You could apply this to any content. The very beginning of this cycle is to ask, that we always kind of start with some questions, some desire to discover, genuine curiosity. In science, often asking questions brings a question about the environment around us into focus, or sometimes a problem into focus that students would be interested in spending more time about this. And I want to be clear from the very beginning here that this is not, even though this image is presented with single directional arrows and as if it goes around in these 5, and yes, we can always come back to ask, but we would only do that after we reflected, that there will be asking that happens throughout. And I have another image that shows that really nicely. So that beginning thing is to begin to ask questions, and it really naturally leads to the next stage in the process, which is investigations. And this is where the learner gathers information. Often during the process of investigation, learners are able to refine, add to, or replace their questions. They get out there, they see the information that's out there and discover that the information that's out there isn't matching very well with the questions that they were asking, and those questions get refined. The investigation, once we have all this information that we've gathered through an investigation, we come to component number 3, which is where we bring together all the information we've gathered, and we represent our findings in some way to compare them to something else, to communicate to something else. And in this process, the learner is making those connections to their initial question. And that goes back to that idea that this is a learner-centered constructivist model, because they're actually creating that explanation or creating that understanding, which is very much about building knowledge themselves. In component 4, they're going to discuss, they're going to share their new ideas with others. Again, this is social constructivism, and so we need to make sure that we're engaging our peers or we're engaging our teacher or guide in the process. We're able to question each other at this point about what we've found, which sometimes causes students to go back through the investigation and creation process to respond to those questions. And as we share that knowledge, we really build community. So we can share knowledge a lot of ways. You could compare notes, you can discuss conclusions, you can share experiences, you can do presentations. There's a lot of ways. You can have them actually write up a report and have them read each other's reports, or you can read their report and provide feedback. There's a lot of places for the discussion to happen. What's most important there is that it's not just about reporting out and moving on, but it is about that two-way place where we're able to share what we learn, be questioned, build community, and respond to those questions where appropriate. And then the last part is reflection. We return back to the question, we look back at our path, we check on the conclusions that we made, and it's an opportunity really to step back and take inventory, make new observations, maybe make decisions. And often that reflection leads us back to the asking of questions. We didn't find out exactly what we wanted to. We now have more questions. We discovered something that's even more interesting. We go back through the cycle again. Okay, so that's the basic inquiry cycle. You notice I did mention the idea of a report, an investigation. We kind of naturally go to the idea of a hands-on investigation or a lab, but those were connections that we were making as science teachers back to our own science content, but the rest of this really could be done in any subject area, and that's really important as we think about the transition in language that we're going through in science right now towards the language of science and engineering practices, instead of just talking about inquiry as a more general term, that everything that we're talking about transitioning still fits within this inquiry cycle, and that this inquiry cycle shouldn't be going away. We should still be going through these 5 stages and allowing students to really be constructors of their own knowledge. So this is another representation that is specific to scientific inquiry. And you can see that this one really centers around questions. And it centers around the idea that as we define problems, we ask questions. As we form the question, we ask questions. As we investigate the known, we ask questions. As we articulate, we ask questions. We carry out the study, we ask questions. And you'll notice that these names that are on the outside are much more specific to science than those generic terms are. But we really, here we're asking questions, here we're gathering information, here we're creating that explanation, here we're reflecting on what we found. It's just different terms for it. And this is a really nice model because it does show that cyclical nature, and it allows you to really think about how you could go back and forth between any 2 parts instead of going around in a lockstep. Okay, this levels of inquiry, I really like this example that shows the levels of inquiry because it does help to kind of articulate that there are different ways to go about it. So if we look on the far left, we have from the very lowest level this close-ended demonstration. The teacher is completely in charge, and the demonstration doesn't have kind of that explosiveness of I'm just showing you this so you can go off and create your own thing. It's just this close-ended thing. Maybe we have a worksheet for them to fill out. Maybe they are going to talk in groups about it. We were going to maybe engage at some point in some levels of student ownership, but it's a close-ended demonstration at heart. We go from there to guided inquiry, and then to bounded inquiry, which would be where the student is doing a lot of the work, but there are kind of some guidelines for the limits to it. And then we have open-ended inquiry. And then a little bit off the chart here, but still very relevant, is this idea of collaboration with a researcher, that we're doing kind of real science. We're investigating something new that nobody knows the answer to, but we are collaborating with a knowledgeable other. across the top, we have the different parts, this idea of the research question, that ask. The study system and methods and data collection would both be part of that investigate. Analysis and presentation would be about the creating and communicating about our work. And then this last column here talks about the scholarly goal of the activity. So kind of outside of the fact that we're doing this and we have our standards and all of that, what's our goal? So I actually want to start here and look. The things that are at the top part teach the existing knowledge by showing or guiding our students to it. Okay, we have a goal for what knowledge they're going to learn. We have a path for them to get there. Whether we're doing a close-ended demonstration and telling them exactly what to do or showing them exactly, or we're doing guided inquiry where the step-by-step process is lined out by us, either way, we're really just trying to guide them to existing knowledge. On the bottom half here, we're actually teaching the process of knowledge construction. Along with whatever science they might learn, they're learning about how to gather knowledge. And on the bottom one, in addition to that, we would be creating knowledge that's new to the discipline in our work with that researcher. So you can see at the very top in the closed-ended demonstration, everything is given to the student. On the next line, the research question and how to do it is given to the students, and sometimes the data collection would be given, sometimes it would be determined, but the analysis and presentation would kind of belong to the student. As we get down to bounded inquiry, we might allow students to write their own research questions, we might give them, we might let them design their own study, we might give them, but the data collection and analysis and presentation would definitely be owned by the student. And then in the open-ended inquiry, we get down to the point where really the only thing that a student could be given would be the research question, and that would mean that we were very intentionally saying this is the topic we're working on, but beyond that, you'll create your own things. I really like that you can see in this collaboration with the researcher, we actually go back to a more almost bounded level because you are working on a given question because you're collaborating with a researcher. And it's possible that everything else could be given as well, or it could be created by the student. The thing that's important here is that we're working with a real researcher. We're going through a very authentic process and we're creating new knowledge, even though the student may not have as much of a voice in that process, it still is a type of inquiry. One example of the collaboration with the researcher that I think is really interesting comes out of ASU in Arizona. It's the Mars Student Imaging Project. And in that project, students are able to actually engage in research using data from the NASA spacecraft that are orbiting Mars. It's a great, authentic research experience that can be done from anywhere, and it's free to sign up. If you want to learn more, you can just search for Mars MSIP, the Mars Student Imaging Project, ASU. It'll come up. It's pretty easy to find, but that's a great one if you're interested in giving students that collaboration with a researcher experience. So we have a classroom example for you to look at, and we want you to watch for a couple things when you're going through this. First, we want you to watch for the parts of the inquiry cycle, and on your paper take some notes about where you see each of the parts. Second, we want you to watch for reading and writing, and take notes about where students are engaging in literacy through reading and writing. Okay. That'll kind of help you as you answer that reflection question for this week that's really broad and general about how is it that social constructivism really uses reading and writing when it's being done well. So enjoy the video and have a great day.